Welcome back to another edition of Who Wants to Be a Mathematician? I'm your host, Mr. Hill, coming at you with some AP Calculus, derivative of an inverse function. So if we have a differentiable function, f of x, and it has an inverse, then the inverse is differentiable at c, and we know that the derivative of the inverse at that point, is equal to 1 over the derivative of our function evaluated at the inverse of c. Well, what does that mean? What does that mean? That's crazy talk. Well, if we have a function, f of x, then we have an inverse, f prime of x. Not f prime, f inverse of x. And we want to take a derivative at a point c. So let's say we have a point, and we want to take its derivative. Well, this derivative is going to be equal to the reciprocal of the function's derivative, so the function slope at that point. Well, what is our, choosing colors, what is our f inverse of c? Well, f inverse of c is merely the function at that point. So if this is c, then f inverse of c is going to be this point. So this is equal to my y value. C is equal to my x value. So if I have this point, x, comma y, then I know corresponding point on my f of x, my function of x, has this same point, only the inverse y, comma x. So what do I need to find in order to figure out derivative of inverse? Well, I need to find out this value right here, and I need to plug it into my derivative function. So f inverse of c, we said, is equal to the y component, but our y component of this variable is equal to what component of this one? It's going to be equal to our x. So that's what we're going to do. We're going to do a little flippy floppy. We're going to find two things. We're going to find the derivative, and we're going to find our inverse at that point. So here we go. Let's do an example. Given. That's nice that they give us things. Isn't it great that math gives you things? Given we have this function, and our x's are greater than or equal to 0, find the derivative of its inverse at a when a is equal to 1. Well, what did we say that f inverse of a was equal to? We said it was equal to what? It was equal to our x value of our function. So we need to find the x value of our function. And we have our little a is equal to 1. And what did we say a was equal to? We said this was equal to our y value of our function, f of x. So if, using these two things, we're going to find the derivative of the inverse. So first off, what do we need? We need two things. We need to find f inverse of c, and we need to find the derivative of our function. So step 1, derivative of our function, 2x plus 2. Nice. Step 2, find our f inverse of a. Well, we said that was equal to our x value, so we need to solve for x. What do we know? We know that a is equal to 1. And what is a? A is equal to our y value of our function. So our y value is equal to 1. So if we put that back into our equation, y is equal to 1, which is equal to our f of x. We know just notationally wise, y is equal to f of x. So that means 1 is equal to x squared plus 2x minus 2. We subtract 1 from both sides. And now we do a little factoring. Remember when we used to do this all the time, all day long? It was the greatest thing ever. And we get x is equal to negative 3 and x is equal to 1. But we have parameters. Yikes. X can only be greater or equal to 0. That's bad news for Mr. Negative 3, but good news for Mr. 1. So now we have found our x value. And what is our x value equal to? X is equal to 1. And our x value is equal to f inverse of a. So now, if we want to find, bring it all home, we want to find the derivative of the inverse at a, we know it's equal to 1 over the derivative of f evaluated at the inverse function at a. So now we just need to plug things in. We have 1 over f prime of 1. And what's f prime of 1? Well, let's come back up here to our top. F prime of 1 is equal to 2 times 1 plus 2, which is equal to 4. So this is equal to 1 over 4, and there we have it. The derivative of the inverse evaluated at a is 1/4. So let's break it down one more time. Step 1, find your derivative. Step 2, find your inverse of a, which is your x value. By using step 3, we are given our y value. This is also known as a. And we use that to calculate all the way down till we get our x value. And then we just plug it in. So 3 steps to do it. Nice. Let's do another example. So here we go. Given that our function is this, find the derivative of the inverse at a when a is 8. So let's list out the things we need, that we know and we need to find. We know that the inverse derivative at a is equal to 1 over the derivative evaluated at our inverse function of a. We know that a is equal to 8, and this is equal to our what? This is equal to our y, which is equal to our f of x. We know that f of x is equal to 2x cubed minus x squared minus 4. Now let's talk about what we need to find. Step 1, let's find a derivative. Our derivative is 6x squared minus 2x, and we know that that is equal to what? Well, we don't know that yet. Just kidding. Step 2, we know that our f of x is equal to 8. So that means 8 is equal to 2x cubed minus x squared minus 4. So doing a little majiggerin math, we have 0 is equal to 2x cubed minus x squared minus 12. Well, that's kind of hard to just, I don't know, do out of the top of your head. So what I'm going to do is you plug into your calculator exactly that. 2x cubed, then minus x squared, follow along with me, x squared minus 12. And we are going to just simply calculate that out. So let's graph that. Ooh, syntax error. Nice. Let's delete that and try that again. So let's graph that. And we're going to find out when it equals 0. Oh, well, it equals 0 at 2. So x equals 2. We just did that by graphing in our calculator and found out when it's 0. So now we have our x value. What's our third step? Our x value is equal to what? Our x value is equal to our inverse at that point. So here we go. Now we just need to plug it all back in. So we have our inverse. Now we just need to find, so the derivative of our inverse at 8 is equal to 1 over f prime of that, which is 2. And f prime of 2, we come over here, f prime of 2 is equal to 6 times 4, which is 24, minus 4, which is 20, is 1 over 20. Boom, and done. So here's what we're going to do now. We're going to do one more little thing in this video, and then tomorrow in class we're going to finish up the packet. So we'll do example 5, we'll do example 6 and 7, all in class, and then we'll do the very last page, which is example 8. But now we just need to talk about derivatives of inverse trig functions. So using all this knowledge of our inverse functions, we're going to talk about derivatives of trig functions. So here we go. We want to find the derivative of tangent inverse of x. Well, if if we have f prime and we want to take a derivative of this function, that's saying we're taking tangent inverse of x and we want to take a derivative of that. Well, we know this is equal to f inverse derivative of x is equal to 1 over f prime of our f inverse evaluated at x. So now we just need to find all our components. And the way we're going to do that, well, we know our f of x is equal to the non-inverse, which is tangent of x. F prime of x is equal to secant squared times our original tangent of x.